All right, for the function problems where there's transformations, there are two like this on the test. So basically, on the test, we give you different ones. So this should just I've said the graph of f of x, and then notice that these change. Once it's a square root, once a cube root, once it's a fourth root. So it just tells you what transformations to do. So you're going to define g, so g of x is going to equal, okay, this one, the parent function was square root of x. So I'm going to use the square root of x, but I want to do a horizontal shrink by a factor of a half. So I want to take all my x's and cut them in half. To do that, I have to put a 2 out in front. It's got to be inside because it's affecting the horizontal, it's affecting the x's. It's opposite of what you think. So if you're going to shrink them by 2, you have to put a 2 times x to make that happen, followed by a reflection over the x-axis. So remember where the x-axis is. That's this one. So what I want to do is I want to take my graph, and for every y I have up here, I want it to make it negative y down there. So I want to affect the y's so that it reflects upside down. So to get it to flip upside down, I need to put a negative out in front of the function. So this shrinks it by half, the x's. This is going to change all the y values, so it's going to reflect it over the x-axis. All right, number 18 is now working with a cubed root. But now I want to do a vertical stretch by 3. Vertical means it's going to affect the y's. So now g of x is going to equal 3 times the cubed root of something, because again, the 3 is outside of the cubed root because it's a vertical stretch by 3. Affects the y's. It is what you think it would do, so when it's stretching it, making it bigger, that number is 3 times the cubed root. Remember up here it's opposite, it's inside here, so when you want to shrink it, you multiply by 2. If you want to stretch it, you divide by 2 or multiply by a fraction. This one is followed by a translation of 4 units left. So inside, if it's going left and right, it's affecting the x's. So if I want to go to the left, opposite of what you think, so if I want to go to the left, I have to put x plus 4. I want to go 4 to the left. Okay? So this stretches it vertically. This underneath the cubed root, that moves it 4 to the left. And then the last one, now we're dealing with the fourth root. I want g to be a reflection in the y-axis. So again, think about y-axis is right here. So I want all my x's to become their opposite. So now I'm going to have the fourth root of negative x. I'm putting a negative inside the function so that every x becomes its opposite. It reflects this way. And then it says I want to go down 7, so that means out here I want it to affect the y's. So now I'm going to minus a 7. It is what you think. Down is minus, plus is up. Again, the negative affects the x's, so it's reflecting over the y-axis. If I want to reflect over the x-axis, I have to make the y's become opposite, so that's why I put the negative out in front. This stretches and shrinks. It's opposite of what you think in here when it affects the x's, the horizontal. So to shrink it by a factor of a half, we have to multiply by 2. To stretch it vertically, now it's affecting the y's. It's out here, so it does what you think it would do. You're going to triple those y values. All right, so that's there. There's 2 of those questions on there. And then let's just talk about the word problems real quick. Basically, all you need to be able to do is, if I'm going to give you 2 functions, read the problem, see what it's talking about. So in this case, it was F was the number of bales you got from the first crop of hay, and S was the number of bales you got from the second crop of hay, which will be less normally. So when you find F minus S, so all you're doing is taking, be careful when you're subtracting, it's this term minus this one, and this minus that. 24.8 minus 14.9. I actually wrote it out and changed all these to their opposite sign when I was subtracting, and hopefully you got that as an answer. I didn't check my answer, but I'm pretty sure that was okay. So then they ask you to find F minus S of 28. So I just put a 28 into this function right here, and I got 202 bales about. That's given that the rainfall was 28 inches, because that's what R represented. Then when it says explain what it means, so just think about what that means. If I take the number of bales in first crop, subtract the number of bales in second crop, with any given R, which is R is just the given amount of rainfall. So what does F minus S represent? It's how many bales of hay are harvested in the first crop, how many more bales of hay are harvested in the first crop with any given rainfall. Okay, so that's all it is. I'm subtracting. How much is F minus S? The first crop minus the second crop. The one on the test will probably look more similar to 21, so I want to definitely talk about 21. So here you're installing a pump in a basement. The pump has a rate, R, in gallons per minute. So sometimes when I get to this, what is R times T, I actually, to interpret it, I actually think about units. So the R, the rate, is how many gallons it can go per minute, and T is the total operating time in minutes. So by total operating time, it means until the pump goes bad. So how many hours or how many minutes of operation are you going to get before the pump goes bad? So in the lifetime of the pump. And they're both related to the cost of the pump. So obviously, you know, the faster it can pump, probably the more it's going to cost. So here is the rate, how much it can pump, how many gallons per minute for the cost of the pump. This is the time, the total number of operational minutes you would have with that given pump that costs C dollars. So the first thing just says, can you multiply? So make sure when you're multiplying, because these are both monomials, you can just multiply the coefficients. So I took 0.017 times 1027 and got 17.459. When I'm multiplying the like bases, I kept the base of C. I have to add the exponents, and I got C to the 2.27. Okay, so that's the first part, is can you multiply, which means you multiply the coefficients, and then you multiply the C's by adding the exponents. So then when you come to what does it mean, again, I just think of R is gallons per minute. T is the number of minutes. So if I take gallons per minute times minutes, which is like minutes over 1, the minutes cancel, so that tells me I'm talking about gallons. So sometimes it just helps to think about the units, like this is in gallons per minute times the number of minutes, that will be how many gallons. And that's probably going to be worth a point, that at least you get that it should be gallons that we're talking about. But how would you word that? Well, it's going to be the number of gallons of water that a tank that costs C dollars, remember C is how much it costs in dollars, so the number of gallons of water a tank that costs C dollars will pump in its lifetime. So while it's working, until it breaks down, how many gallons you can expect it to pump if you spent C dollars. So again, word that the best you can. I'll be pretty lenient on that, but I really am looking to see that you know that it's, if it's gallons per minute times minute, you're really looking at the number of gallons that it will end up pumping throughout its lifetime. All right, so definitely look at number 21, that you can do one like that.